Now this brings us to another thought leadership talk for which I would like to warmly welcome on stage Dr. Fiaz Ahmed Chaudhry, Director, LUMS Energy Institute and CEO, Engineers Guild, to please come and share his views on engineering the future and innovation in smart buildings.
Assalamu alaikum, everyone.
Hello.
So this
Hello.
is,
Hello.
you'll see, this is a different diagram than engineering building, or you can say any, the reason I'm showing this diagram is the power system. So what relationship you have with the building. So this is what we need to understand today. So if you take one message out of my talk today, I think my job will be done. So power system primarily consists of three elements. One is a generator, transmission system, and your load. And when we talk about load, the building comes in. So how this building is impacting the power system load, and how overall the power industry is in shambles due to our buildings. So that is what you will understand from here. So there are, one is, for any power system, you need to understand what the supply mechanism, what the demand is. But that's how you will, provide the optimal solution to supply that load. And that's where we are lacking. We lagged, in a big way. We didn't plan it properly. And you will see in a minute. But then this power, sector has to be structured appropriately. You have NAPRA, you have other organizations. So it means whatever decision that you need to take, because it requires huge investment, it has to be formalized, it has to be taken through evidence-based analysis. Everybody talks about circular debt, nobody really knows what the real cause is. We think about, maybe some theft is maybe an issue. Non-recovery, yes, partially that could be an issue, but is that the real reason? Which I believe it's not. Now, here, if you look at the typically daily demand profile to which the power system or the system operator has to meet that demand, it varies on a daily basis or on a yearly basis. So this graph shows you. Can you see this? Yeah. No, but okay. Yeah. So here is the building could bring this peak, and here at night you don't have much load. But your installed capacity has to be way above your demand to have some sort of reserve margin. So in Pakistan, you will see in the graph that I'm going to show next. So here is the planning mechanism. You decide on the type of power plant that you need to install, either renewable, hydro, fossil fuel, and here is the duty that some of the plants may not be able to even provide. This is, we call it ramp rate, because in the morning when you come to office, your demand increases drastically. So it means your supply system has to, cope with that demand. But here, when you do not have much demand, all this installed capacity that you see maybe up till here, so it means you are not recovering any cost. So this is a fixed payment. So I'll go quickly from here. So the one decision is your capacity. So we have installed over 40,000 megawatt of capacity in the NTDC system, for which we are paying those capacity payments. Everybody hears about it. But are we really, how much are we using them? So the second decision is on the energy. So if you plot your demand in the reverse order, in the descending order, this is your peak, then you have to see how much time this peak stayed on the system. So this is your minimum demand in the year. So we call it a base load. And this is during the variation that you saw in the previous graph, and here is your peak. Now, this is I'm building a background for you so that you understand, in the next few slides, so that, you have some sort of a background knowledge. Here is our country's demand, which is about 139 terawatt hours. And only two provinces, which is Sindh and Balochistan, they only account for only 19%. The rest of the demand is north of Guddu, 81%. Now, and your power plants are the cheaper plants, I would say, which are base load plants. Those are installed now here, in this area. Thermal, nuclear. So all your cheaper energy is in the south. So it means, but the demand is not that much. So all this power has to be transported to north because the demand is here. 67% of your country's demand is in Punjab and Islamabad. So the hydropower plants that we have, they only work in summer, July, August, and September. But then you do not, although you have over 10,000 megawatt of installed capacity, but they do not supply to their peak capability because water is not available. So you have challenge. And we created challenge for ourselves. How? Keeping in view that our demand is growing, and then growing it very fast, not realizing why this demand is growing. So what we did, we planned, and this is all committed. All this is installed capacity. So we are going in 58,000 megawatt in 2030. That's what our generation capacity will be. And here is your availability because of hydro conditions or whatever. Basically, this is demand. But still, although we say we do load shedding, we do, I don't know, but this is your surplus capacity you have in the system, unutilized idle capacity. And this is reality. Now, this is one graph that I can spend half an hour easily only on this graph. This is the data from 2018 till 23. And this is from system operation. Look at these months. 4 months of winter, where the demand is. And these 4 months, we have a consistent behavior. So demand is not increasing, peak demand is not increasing more than 12,300. At night, it goes to 8,500, 8,300. So this is the portion which we do not supply no matter what. This, why? Because of, law and order situation, because of theft. So this 2,000 plus megawatt, and here in summer, 3,000 plus or 4,000 megawatt
Hello.
plus we do not supply.
Hello.
We call it rotating load shedding. But yet, if you see our peak demand last year, this summer, in August, it 31,270. And in winter, it is how much? 8,000 at night, 12,000. So difference is almost 17,000 megawatt. So what this demand is that? This demand is of cooling load, 17,000 megawatt. And it is due to building. So whatever we have invested in the last 6-7 years, the number will come here, $84 billion. 84. And for which the entire country is paying debt servicing to supply what? 18,000 or 17 plus thousand megawatt of cooling load. So it means this is not sustainable. So the other graph that I showed, that utilization, you'll see the utilization of that asset that you developed is very low. So you cannot even recover the amount that you invested, no matter how much hike you do with the tariff. So here, just important information. And this is from actual, nothing is cooked here. This is actual because I was, part of NTDC one time. So I have a MOU with, system operator, which is, and CPPA at LUMS. So we receive this data. Not easily this data is available outside. Only 85 hours, this NTDC supplied 24,564 in summer of 21, in summer of 22 rather. So I said, if you reduce it to 1,000, how much time did we require the last 1,000 plant, 1,000 megawatt? Less than 85 hours. Another 1,000, only 400, less than 5%. Now, this year, demand was this, which later on, this is actually supply, not demand, this is load that we supplied. Demand was later on in August, it was 31,000 that I showed you the number. So look at here, 3,000 megawatt. The top 3,000 megawatt of cooling load was only supplied less than 5% of the time. So now let me show you what the investment cost of that 1,000 plant is. If you reduce that 1,000 megawatt of installed capacity that you do not require, you develop an appropriate building. This is the cheapest plant that we installed in the last 6 years. $124 million is its capacity payment. $921 million is your operating cost. So total you will save more than $1 billion by reducing your demand by 1,000. So this is what we did. That is why your tariff is high. So everything has gone through the roof because of our wrong design or uninsulated buildings. So this is the, now this is the energy supplied. Energy is supplied in the last, at least 7 years. Here, as you know, we did not have enough capacity. We were doing 10 hours, 12 hours of 18 hours of load shedding. But here, in 2018, we had enough capacity. But the demand did not grow that much. But here, demand grew because some industrial activity started in 2020-21. But in 22, we are back because the industrial activity has relatively stopped. And the dilemma here is your 56% of the total demand is your domestic or building load. Now, to prove my point further, this is winter months, 4 months that I showed you, 4 months. In 2010-11, our total 4-month demand was 25 terawatt hours. From 25 to 33, how many terawatt hours we added? In 13 years, only 8 terawatt hours. So it means country has not progressed. This is less than 1% of growth. So your even population has grown more than this percentage. So country is stand still, rather going backwards. So although we are going backwards, but still we are stupid enough to increase our summer demand, and which is rising exponentially. So what should we do? This is, I dissected 1 year, with the last previous year, 143 terawatt hours, out of which 41 terawatt hours we sold for air conditioning or for the cooling load. Otherwise, we would have sold 1 or 2 terawatt hours if we would have, let's say, assume, the summer never came in Pakistan. So now this 41 terawatt hours of business, by installing 21,000 megawatt of capacity with only less than 28% of utilization. So it means, what sort of tariff will you increase? How will you recover this cost? So we introduced this circular debt in design. Not even, forget about recovery, forget about T&D losses. This is all, wrong understanding. Now the situation has not gone better. Next year, only 30 terawatt hours for cooling load utilization, but your demand that you try to supply by spending $84 billion, हम दीवारें ठंडी कर रहे हैं. And how much population can afford this sort of luxury? Maybe less than 10%. So the less than 10% of the people has crippled the whole nation. So the whole, although the topic here is a building, but so that's why I wanted to give you a perspective from the energy, the overall countrywide. मैंने तो 5-4 AC लगा लिया घर में because I can afford it. But countrywide, how much, impact I did. That whatever 10% or 12% of people, ये आपके सामने है. अब आ जाए इसका करना क्या है? लेकिन अच्छा, हम अभी यहाँ बाज नहीं आए. हम पहले घर को ओवन बनाते हैं, फिर उसको ठंडा करने चलने पड़ते हैं. सर्दियों में पहले हम उसको कोल्ड स्टोरेज बनाते हैं, फिर उसको गर्म करने के चक्कर में पड़ जाते हैं. सो दैट्स हाउ आवर बिल्डिंग एंड डेवलपमेंट. अब ये देखिए, ये विंटर में हमने $2.7 बिलियन हाथ सेकने में गुजार दिए. और यहां हमारे पंजाब में सारी पाइप गैस है, तो कौन सा वहां माइनस का टेम्परेचर है कि आपने ये $2.7 बिलियन आपने हाथ सेकने में लगा दिए. तो ये लम्हा फिक्रिया है. तो हमें अपनी कंस्ट्रक्शन मेथोडोलॉजीज को, अप्रोचेस को रीवैम्प करना है. तो अब आ जाते हैं कि भी ये आपका जो बिल्डिंग एनवेलप है, हर तरफ से ना आपकी रूफ सही इंसुलेटेड है, ठीक है, आपकी सारी उम्र से पिछले 50-70 हमने रोशनदान बंद, ऊंची छत बंद, खिड़की बंद, बरामदा बंद. हमने क्या किया, वो लाल ईंट से जान नहीं छुड़ाई. सारा दिन हीट एब्जॉर्ब करती है, फिर सब छत में हमने कंक्रीट डाल दिया है, वो आपको सारी रात रेडिएट करती है वो हीट. सो वी नीड टू डेवलप सम बेटर एनवेलप. ठीक है जी. सिंगल ग्लेज विंडो, लीकेज हो रही है, नोबडी बॉदर्स. फिर हमने वो जो थर्मल ब्रिजिंग है, اس کا کچھ ہم نے کوئی بیریئر نہیں لگایا, کوئی ٹرانسفر ہوتی جا رہی. ٹھیک, ابھی ہم نے انالیسس کیا, ابھی ہم نے 13 دسمبر کو وہ انشاءاللہ رپورٹ پبلش ہو جائے گی. اب یہ آپ ایک الگ سے 10 مرلے کا گھر ہے, تو ہم نے یہ جو ابھی بات ہو رہی تھی بلڈنگ انفارمیشن مینجمنٹ میں, وی ہیو اسٹرانگ اسکلس ایز لمز انسٹیٹیوٹ ایز ویل ایز انجینئرز گلڈ. ہم نے انالیسس کیا کہ اگر میں گھر کو تھوڑا انسولیٹ کر دوں, تھوڑا ایفیشینٹ گھر بنا دوں, تو میں پیک ڈیمانڈ میں یا انرجی میں کیا سیونگز لاؤں گا. اب یہ ذرا دیکھ لیجئے, وہ جو آپ نے پہلے کہی کہ ذرا پلاننگ کر لو, ٹھیک بھئی فیسلٹی مینجمنٹ تو بعد میں ہے نا, وہ جو ڈیزائن کی باتیں ہیں پہلے وہ تو درست کر لیں, مینج کر لیں گے اس کو بعد میں. تو دس از دی کائنڈ آف امپیکٹ. اب یہ جو پرسنٹیج نکالی ہے یہ پورے سال کی ہے. اگر میں اس کو یہ 8 مہینوں میں لے جاؤں, جو کہ 4 مہینے ونٹر کو نکال دوں, یہ 60% سے اوپر ہو جاتا ہے. سو اوور 50% سیونگز کین یو ڈو. اور اس کا کیا کریں؟ اب جو بجلی آپ کے لوگ پیپل کوشچن وٹ شوڈ وی ڈو ود دی انسٹالڈ کیپیسٹی ناؤ. ڈونٹ وی ہیو over 4,000 megawatt of captive power plants? Why don't we supply this relatively more efficient plants we have built? You know, the plant that we, I spoke about, 62% efficiency ہے اس کی combined cycle. So what we do? ہم گیس کو انڈسٹری کو دیتے ہیں 6.5 یا whatever ڈالرز MMBTU کا. پاور سیکٹر 9 جب یہ $7 کی تھی تو اس کو سبسڈی بھی دے رہے ہیں, اس کا پلانٹ بھی 40% والا. تو ہم وہی گیس 62 میں برن نہیں کر رہے, صرف اپنا وہ جو ڈسٹریبیوشن کا یا ریلائبلٹی تھوڑی اگر کوئی کنسرن ہے انڈسٹری کو, ٹرانسمیشن یا ڈسٹریبیوشن, اس کو تھوڑا سا, اور اس کی تو پیسے ہی بہت کم لگتے ہیں, اس کو تھوڑا ری انفورس کر کے ایز اے کنٹری اوور آل ایک انٹیگریٹڈ اپروچ کے ساتھ یہ آپ کو کام کرنا پڑے گا. تو ابھی ہمیں کیا کرنا ہے؟ ٹارگٹس بنانے ہیں. تو ہم نے یہ انالیسس کیا کہ اگر میں پورے ملک کو 100% ایفیشینٹ کر دوں, 11,500 میگا واٹ کی کیپیسٹی مجھے نہیں چاہیے. اینڈ ایچ وہ جو میں نے 1,000 کو آپ کو بتایا ہے, وہ پلانٹ کتنے کا لگتا ہے, کیا اس کی انویسٹمنٹ کاسٹ ہے, کیا اس کی آپریٹنگ جو لائف سائیکل کاسٹ آپ نے بتائی, کہ جب تک وہ اس کو آپ نے ماؤتھ بال نہیں کر دیا, جب تک آپ نے, تو تب تک کاسٹ سے رہنی اس کی فیسلٹی. سو اصل ہمیں کیا کرنا ہے؟ اپنی بلڈنگ کو امپروو کرنا ہے. اور بلڈنگ سب سے انویلپ اگر آپ نے درست کر دیا, اس کا پراپرلی اس کو انسولیٹ کر دیا, ایٹ لیسٹ 40% آف یور سیونگز آر رائٹ دیئر. اور دین باقی یہ ذرا سوری, ہم اکثر ہمارا جو نیکا ادارہ ہے, نیشنل انرجی ایفیشنسی اینڈ کنزرویشن اتھارٹی, وہ ان کا فوکس یہ تھا کہ اپلائنسز کو درست کر دیا جائے, ایفیشینٹ کر دیا جائے, فین بہتر کر دیا جائے, موٹر بہتر کر دی جائے. تو ہم نے اس کا بھی امپیکٹ نکالا کہ اس کا امپیکٹ یہ ہوگا, اگر ہم نے ساری اپنی اپلائنسز کو آپ نے ایفیشینٹ کر دیا, دس ول بی دا امپیکٹ. لیکن اگر میں نے بلڈنگ درست کر دی, دس از گوئنگ ٹو بی دی امپیکٹ. اور پھر کیونکہ ہم نے یہ پریزنٹیشنز منسٹری آف انرجی میں دی, نیکا کو دیا, پریزنٹیشنز دیں, تو اب یہ ہے کہ انرجی کنزرویشن اینڈ جو بلڈنگ کوڈ 23 بنا ہے, تو وی ہیو سبسٹینشلی کنٹریبیوٹیڈ. اب وہ کیبنٹ سے اپروول ہو گیا نیا بلڈنگ کوڈ. ہوپ فلی اس کی امپلیمنٹیشن وہ ہم نے سوچنی ہے ایز بلڈرز, ایز آرکیٹیکٹس, کہ اس کو ہم کتنی جلدی اس کو امپلیمنٹ کر سکیں. اب یہ ہے کہ اس کا ایک فائدہ تو ہو گیا انرجی سائڈ پہ. انوائرمنٹ سائڈ پہ آپ یہ دیکھیے کہ آپ نے اگر یہ بلڈنگ درست کر دی, آپ کا جو کاربن ایمیشن ہے اس کا جو امپیکٹ یہ بلڈنگ ڈال رہی ہے وہ اتنے ملین ٹن کا ہے, اور ایئرلی سیونگ آپ کی 442 بلینس، اور یہ آپ کا 572 بلین جو آپ کی جو سوشل، جو آپ کو کوئی بیمار نہیں ہوگا، پولوشن کم ہوگی، تو یہ انسلری بینیفٹس ہیں. So that's how this building is causing us grief. So let's try to build better buildings. Thank you ji.